Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. My name is Tanvir Khan. I'm the student of Mechanical Engineering Department and studying Manufacturing Automation Systems. Today I'm going to perform classification tasks. Uh, this one is my data set, which comprise of inputs data and target value. So I will classify the target value based on into three classes. So for that I need to upload the input data and target data. So I will start from the Matlab scripts. So first I uploaded the data, uh, the input data, like for the, and this one is the target value. So let me clear the previous one. Your all see. Okay, so I uploaded the data. Okay, then after that I found the difference of the target, like this value, y is the target value. So I could take the decision based on those differences. If the difference is like 0, so it will be 1. If the difference is like in class 1, if the difference is less than 0, so it should be in like class 2. If the difference is equal to 0, it should be in class 3. That's why I need to find the uh, differences. Then I created an variable of the same size of the price difference, and store the non values in the y3 class variable. So then after that, if the difference is greater than 0, so the value should be stored in this variable 1. If the difference is less than 2, so less than 0, so it should be 2 in that variable. If the difference is equal to 0, it should be 3 in that variable. Okay, and then after that I learned the original, this one with the original, the y class. So with the original data, so I for that I included null row in that one. So now it's in the same size like the original one. Okay, after that I remove all the non values from the x and from the y3 class variable as well by using these functions. So I remove all the non values from there and split the data into training and test data. I split the data into 70% of the training and just 30% of the test. And then I divide, like then I call the x vector of the same size, like of the same row in one column. And then I divided the train ratio and test ratio into the feeding in the train ratio and test ratio, and store the indices and train indices and test indices, right? And then after that I call the x and feeding the this train indices in all columns and store the x train, and y train I call the y3 class and then feeding the train indices and store in the y train. Then I call the x and feeded the x test indices in all columns, and y test y I call the y3 class and then feeded the test indices and then store in the y test. So we have data now like x train, y train, x train, and x test and y test. Okay, now we will start from the NN classification model. Like for that I choose the number of neuron 10, and then I call the functions pattern neural network and feeding the number of neurons, like I represent with the hidden layer size, like how much size is that one. So it depends on neurons. That's why given the name hidden layer size and store in the net. Okay, then after I assign the last layer like ending layer, uh, output layer, the assign the softmax function. Okay, then I like it's call these net and then divide parameter dot ratios is equal to 70 by 100, and the similar way is like for the value ratio and for test ratio as well. So 15% like 15 100 divided by 15, it is like 1.5 ratio and 0.15 ratio, and 0.7 ratio is for the train ratio, and for the validation is 0.15, and for 0.15 for the test ratio. It should be like completely 1, right? Like if we sum up like 0.7 plus 1.5 plus 1.5, it should do like 1, so it is complete 1. Now we will convert the target to categorical for multi-class classification. So for that I need to call the full function, and then first I need to call the n to vect. This is a function that convert the one heart in what one the one heart encoding for the training, right? So it will convert into white train, but I need to transpose that first white train, right? And then it will convert into the one heart encoding for the, you can see the result of this one as well, like how it wait, I will start from here. mm, you can see the result of this one. So white train category, right? White train category, white train. So you can see it is like in the corresponding, like this value represent true, this represent false, right? 0 represent false, so it will be responsible to that class. If the class is like true, so it will be 1, right? And then after that I train the model like reading the network and X train and Y train category, yeah. So for that I need to transpose the X train as well, so that's why I choose the transpose the X train. And then I test the model by calling the net, and then I reading the X test values by transposing them first, and then that give us the Y predict. So let's see what should be the result of this one. Evaluate it. Right, so now we will see Y predict. This is the results. Okay, now we will find the maximum of the Y predict, and then we need to find the accuracy. For that we need to sum up of the Y predict class transpose if if that is equal to Y test, right? And divide by number of elements in Y test. Okay, so that will give us the accuracy. So we need to display the accuracy in the command window, so that's why I place the display command here, window code here. And then we need to show the confusion matrix as well, so that for that I need to use this function in to vec, and then feeding the Y test transpose as well as the Y predict. Okay, so that will give us the confusion matrix. So then this code will view net will show us the network structure. So we will start from the beginning again. So we will start. So it is 84% correct, 15% is not correct. So this code has this model has 10 neurons, 3 outputs, 5 inputs. So you can see here. So this is for the wrong, this is for the correct, this is for the prediction, this is for the wrong predictions, this is for correct predictions. So one is predicted 86.9%, two is predicted 22.5%, and 3%. There is only one. There is a 0.2% wrong prediction for 3. Okay, and overall, like for the whole model is 84.6% is correct, but 15.4% is not correct. Okay, let's see. Now we will try with the GUI. Okay, here is 84.6% correct. Okay, now we will go to the first we need to clear this off, clear all, close close all, CLC. Okay, I need to create input for storing the input vectors. Okay, and then same for the target. Okay, then I will copy values from here for the input and copy. Okay, and I will paste over here. Okay, the same for the target. So target is also here. Sorry, no, for this one I need to find the hard code matrix. So first I need to get the formula here, put the formula, this one, copy to find the differences. Okay, you can see here I subtracted from this one. If it is 0, so it should be 1. Uh, if it's like less than 0, so it should be 2, or else 3. Okay, so we will drag this down. Okay, and then I'll put another formulas. This is for increase, right? Increase class, increase I represented it by 1, and then decrease I represented by 2, and no change class I represented by 3. Okay, I will copy the formula from here, copy and paste. So for increase, like if the value is 1, so it should be 1 right here, otherwise it will be 0. Like if I copy this one to the here, so like here I need to put if the R3 value is 2, so it should be 2, right? And so then it should be here like 1, correct 1, and this is what, otherwise it will show me 0. So it is 2, so it is 2, right? So it shows me 1. So it is it is 1, so that's why, and it is 2, so it shows me 0. In a similar way for this one as well. So if it's like 3, can see here 3, if it is 3 should be 1, like it should be also 0. So I need to drag down formula. Similar way, this one as well. Hard code, we call this hard code matrix. In a similar way, this one as well. So there is 0, but still there is uh, one value. It choose 3. I will show you now. If I find out 1, you will see 1 here. Yeah, here. So you can see here there is only one class, but let's see what happens. Now we will upload this hardcode matrix. Wait, not this way. Okay, this way. Okay, we will copy this into target. Okay, yeah, paste. Now we will transpose the input equal to input transpose. Okay, and target as well. Target transpose the target as well. Okay, now everything is already been transposed. 3, yeah, 5. Okay, now we will call the and in start. Now we'll choose the filter aggregation F and then press next. And load input data, load the target data. It shows you like 2416 samples, 5 features, 2014 or 416 samples and 3 elements. Next, 15% for the validation and testing, and training for training 70%. So it will like the for sample we have 1692 samples, and for the training and for the validation and testing we had 362. Okay, then next we will choose the okay number of neurons 10. Okay, okay, number of neurons, it shows number of neurons. Okay, then we train the model again. Okay, then we plot the confusion matrix. So at the model in GUI, like the training is not that much good. Like we can see here, like it shows me the overall accuracy of 50.77% as compared to the script. In the script it showed me 84% corrections. Yeah, so like script is more controllable as compared to this one, so that's why there is a difference between the scripted one and the um, script one and the model one, the GUI one. So let's okay, now we will see. Okay, finish. Okay, so this was our, we can also store the video, the function as well from here. Like you can, yeah, this is the function that we can use anytime. We can call it and use anytime. And then we can also use save result as well. We can use for prediction later on. So if we call that one, 7, okay, Now we can use this neural network and predict the result anytime we want. So this was all about the classification task. So the scripted one was more controllable, so I used that scripted one, like the this one. So I use this code for classifications for three uh, uh, categories. You can see here the whole code, and I feed the softmax function for the multi classifications. So that this one is more controllable as compared to GUI Matlab toolbox. Thank you so much. Assalamu alaikum warahmatullahi wabarakatuh.